doing that.
All right. Hi, everybody. My name is Stefan Reinauer, and I am live here with you from California in the US. And today I'm going to talk about AMIFuse, which is a project I did over my last Christmas break. Um, and the goal of AMIFuse is to read all sorts of Amiga disk images on modern computers. And now, you guys said like there's like a lot of tools that do that already, right? However, like my approach, my thought was like there are a lot of different formats that were used back, file system formats that were used on the Amiga back in the day, and not all of them to the day can be easily read or written on modern computers. So a little bit about myself. As I said, Stefan Reinauer. I started on the Amiga back in 1987, and went learned to write software on the Amiga. Eventually, in the 1990s, my Amiga died, and the last action I did on my dying Amiga was to copy my Workbench disk and the kickstart to an MS-DOS floppy disk so I could potentially write an Amiga emulator. But of course, I didn't know what I was doing, and so the disks were just sitting there until I found the Amiga emulator UAE, and that was back then still called the unusable Amiga emulator. So I started working on that a little bit and tried to make simple improvements. Like I think I implemented Zorro support, which is the bus system on the more advanced Amigas like the 2000. And then in 2010, I moved to the United States from Germany. Back then, I decided to leave all of my computers at home in Germany. And who brings computers to Silicon Valley? That seems like a silly thing to do. 10 years later, I regretted it and got myself an Amiga 4000, got some hardware with it. And I was thinking, I was like, hey, I could go back to working on Linux on the Amiga and maybe write some kernel drivers. But by then I found out that Linux on the Amiga had become unbearably slow, and so I started looking for other projects. In 2021, during the pandemic, I bought a an old SCSI controller, an Amiga 4091 off eBay, and when I looked at it, I found that all the components that are on there could still be bought, either used or new even. And so I talked to my friend Chris Hooper, and I was like, "Hey, we should really recreate this device, right?" And so that was how I got into storage. And once you're in storage, of course, then you look at all sorts of disk images and formats, and or like, hey, how do you actually get to this data when you're not running on an Amiga directly? And so in end of 2025, I came up with AMIFuse, which is what this talk is about. So there were, of course, solutions before how to read Amiga file systems on a modern PC. For example, on Linux, there is a fast file system driver directly in the kernel. So as long as you have a fast file system disk image or disk connected to your Linux box, you can just mount it. But unfortunately, that driver still to the day has a number of bugs, and it's doesn't support all of the variations of the fast file system very well. Like there are extensions like directory cache or long file names, and there's a lot of edge cases, and so you very often you get like some sort of corruption when you try to read that using the Linux driver. Then I found on GitHub, I found this cool project called AmiTools, which has a number of subtools to modify your Kickstart ROM or to emulate certain parts of an Amiga, and also one tool specifically around disk images, floppy disk images, and hard disk images, right? And it's called XDF tool. XDF tool is super awesome. It's very useful. I use it in a lot of my projects. Unfortunately, it also at the time only supports the fast file system. And then the ultimate solution, of course, is you use directly use an emulator like WinUAE or AMIBerry or FSUAE, right? And there you can, as you saw in Dimitri's talk earlier, you can directly mount a local file system, copy files over. Um, Back when I started, I did not know about the host tools, so I thought like, wow, this process is fairly awkward to use, and it's a little bit hard. You have to run in the emulator. You have to switch between the emulator and the host system. I wanted just something that I can use to copy files directly from one volume to another volume. And then I was thinking, it's like, how do you do this, right? Like I wanted back in the day, my problem is I had a professional file system 3 hard disk that I wanted to read, and I really did not want to rewrite the PFS driver for Linux, and then it doesn't work on Mac and it doesn't work on Windows. So I was like, hey, the smarter idea would be, of course, to run the original file system driver directly on the host system. And so this is what amifuse set out to be. So here's a quick overview what the chain looks like. All the way on the right, you see like a disk image. This can also be directly like a disk that you plug into your computer, connecting it to a SCSI controller or through USB in some way. And on top of that runs an AMIGA OS handler, which is basically the original file system driver, right? And the original file system driver, it gets executed by amifuse, which then on the other side talks to the fuse user space file system interface, which has Python bindings, and it allows you to basically write a file system driver in user space. And the nice thing about it is Fuse exists already in various variations for Mac, for Windows, and for Linux, and probably other operating systems. And on top of that, you can just then use like all the tools that you know, right? Like on Mac, you can use Finder, or on Linux, you can use LS and all of your other tools, VI, if you wish. Copy files over. And so Fuse, basically the command chain looks like you run your command or here in Finder or in a shell, right? It gets transferred over on amifuse. Then next, it has like a small bridge basically that handles like the different DOS packets and knows how to funnel everything into an emulator, because of course the original file system drivers, they're all written in a Motorola 68K code, so you cannot natively execute it. I found that because I wanted to use this as an opportunity to learn Python a little bit better, and so I found that Vamos from the AmiTools suite was already written largely in Python and implemented a lot of AMIGA OS function calls in Python. So I decided that would be an easy way to extend it and still have the program run on all different kinds of platforms. And then Vamos executes the native file system handler, and below the native file system handler, you have like your which I basically it's a fake SCSI device, which then we can connect to either a local disk or a local just a file system image. And so there's different types of file system images. I'll get to that later.
I'm sorry to interrupt. Just to be sure, I think we are still seeing the first page. I don't know if you are seeing pages.
Did I mess up the? Let me see.
At least on my screen.
Okay, something is going wrong.
Yeah, now it's. Now I can see the workflow there.
Oh, okay. I am so sorry. All right. Let me. the so that was it.
We follow the explanation. That's okay.
We are yeah, we are here. So what features does it update now? Do you see the feature set slide?
I can see your mouse moving, and it says feature sets follows the
Yeah.
real workflow. Yes, yes.
Okay. Excellent. So amifuse has a number of features. The first one that I wrote was like I wanted a tool to just inspect the rigid disk block, which is the file system, the partition table format of the Amiga, and get some information out. So there's like an inspect tool built into amifuse, which will tell you what sort of disk image you're looking at, right? And then the most important one undoubtedly is like the mount functionality. So you can mount your disk image from the Amiga directly as a local volume on your host system. And then, of course, there are also a couple of ways to modify the file system. So originally, when I started out, it's like, okay, we're going to do this first just as a read-only exercise to get to the old files. But as that progressed, of course, you want more features, and you start using the tool for just dealing generally with Amiga images. And so I added a read-write mode, so you can modify your file system. You can install software into your Amiga image directly without using an Amiga emulator. And you can also do stuff like format your hard drive with a specific format. So if you want to set up a new Amiga hard disk image, you can put an RDB, a partition table on there, and then just say like format this with PFS or fast file system. And then I also had added a layer for handling metadata, so speak icons. So this is most developed right now under macOS. There's some initial support for Linux and Windows, but that still has a little bit of ways to go. So you can configure amifuse to actually show you in your macOS Finder the original icons, and the code knows how to render different types of icons. So there's the traditional Amiga OS icons. There's two other formats, new icons, which I believe was used by Amiga OS 4, and then the glow icons, which is the somewhat standard on Amiga OS 3.2 and the modern 68K format operating systems. Now, one thing I learned, of course, I wanted to test amifuse with a lot of different disk images, and I put the first version out. It was barely working, and I got a lot of bug reports. Right? It's like, hey, I wanted to use a floppy disk image, and that didn't work, right? Or then there's other disk images like what if you use the CD file system on the Amiga, which is basically parsing ISO 9660. But then there's also other variants out there. So EMU 68, which is used on the PyStorm, has its own format where you have an MS-DOS partition table, and then within one MS-DOS partition, you have the actual Amiga partition table. So I added support for that. You can handle your EMU68 disk images directly. And then Parsero also does a similar thing, which is a nice little expansion for the Amiga 1000, which gives you a hard drive by sticking in a little SD card. And so the file system handler, one thing I also learned is like it's not just like a strict parser of your file system. There's a lot to it. Basically, as it's just a normal 68K program running on the Amiga, it can reuse all sorts of system services that it wants, right? And I found out that the original fast file system has very few requirements to what the emulation, what the Amiga OS actually needs to provide to parse the file system. However, then SFS, the smart file system, came around, and I learned that there's a lot more to this than I originally anticipated. So SFS, for example, needs at least the 68020 CPU, and it will spawn its own tasks. So it runs basically multitasking on the Amiga. And that is one thing that Vamos, when I started this project, did not even really support. And then there's you have ports and signals, and the file system communicates with its subtasks in various ways, and with the operating system in various ways. And a lot of that was basically just very simple in Vamos when I started in AMI tools. So I had to expand these to really provide all the functionality that the various file systems out there are using. And as far as the programming languages goes, one thing I thought was like, hey, I need like some sort of 68K emulation. I found Vamos out there. I thought it was a pretty cool tool because it ran everywhere. Was fairly simple to install, right? And I wanted to piggyback on top of that. So the advantage of going with Python here is like it's really portable. It runs on a lot of different systems. It's easy to iterate very quickly. And especially since I was starting this as a quick hack that developed more and more and more, this was very convenient originally. And then there's other stuff that's nice about it. Of course, fuse bindings already existed and were very easy to use on Python. And last but not least, you want to make this available to people. It's very easy to deploy Python programs on all sorts of systems using pip3. And of course, there's a trade-off, right? Python is maybe not the most performant way to solve this problem. So what happened then, once I had everything working, I noticed that it was incredibly slow. So it would take, you run an ls on your newly mounted file system, it takes several seconds to get anywhere. So I had to learn about how to profile Python programs, and luckily I found this tool cprofile, which will run your workload. So I mounted my file system. I did a couple of instructions, did an ls, a find, open the file. And then what it does, it dumps you a list of all the functions and the number of times it has been used and how much time has been spent in there. And so I looked at always the highest offenders, and I was like, okay, this is something that I really need to optimize. And then I tried again, and it became a little bit faster, and I ran the profile again, and it's a rinse and repeat until I was happy with the performance. And then I found out also, like, I released the first version and it worked, and the performance was okay. I released the second version, I added more features, and I didn't even notice I made it twice as slow again by making a mistake in the way I wrote my code. And it was brought to me by one of my testers. I got a message on Discord saying like, "Hey, like I thought this was pretty fast, but now all of a sudden everything is very slow." So I found the need for starting regression testing, because then I fixed the speed problem, and all of a sudden I started getting read errors, accessing file systems. So I was like, wow, like this is really getting complicated enough that if you tighten a screw over here, all of a sudden something becomes loose over here. We need like some proper testing for this, especially if people want to use this to access their old data, and that's very valuable to all of us, right? We don't want to lose these memories just by using some modern tools. So I added a number of tests, a couple of simple unit tests for the CLI, and that everything works. I added some integration tests doing testing all of the different file systems that are supported. I'm doing mount tests, see that I can mount all of them, access all of them, write all of them. and then some smoke tests that test like the various images that the system now supports, and also measures the performance of the whole system. And once I had that working, I going back to my original project that I was working on, the building a SCSI controller, I really wanted to have my SCSI controller boot from CD. And so I found a CD file system that I had been using that was somewhat open source. The source was not available. It was not an open source license. The code was from the 90s. It was pretty terrible, to be quite frank. It's a CDVDFS, right? And when I started looking at it, I wanted to make more changes to it. And I reached out to the author. The author was nowhere to be found because everything is like 30, 40 years ago now, right? And then I was like, hey, I should write my own CD file system. And I called it OD file system, optical disc file system, because I wanted it to also read DVDs and Blu-ray discs. And actually, amifuse made it very, very convenient to get going very fast and iterate on developing a new file system for the Amiga, because I didn't have to copy the new file system into an emulator first and then try to run with maybe like limited debugging, right? I could just run the new file system in amifuse, and then I would get an instruction trace. I would get serial output from the driver. I would get everything that I need to actually make very quick progress, and iterate on writing a driver. So this tool, amifuse, it's also very useful if you're actually wanting to develop new software, new file system drivers. Yeah, and then another interesting part was there. I found looking at all these images that were out there, I found that everybody is doing like something a little bit different. I mentioned earlier already, EMU 68 reps RDB images inside of just an MS-DOS partition table. But also there were other things like the Parsero file system blocks. I could somewhat read some of the data on these images, but I found that like all of the partition table checksums were showing up to be wrong. And I was like, wow, what is going on here? Is this like maybe something that David Dunkley, the original author, did on purpose because he wanted to make sure that the images are not accidentally used somewhere else? But so I decided to just send him a message, right? And I was like, hey, like I found this oddity here, and turns out he had an off by one error in his checksum code, and it turns out a day later he sent the fix around, and the problem is fixed. So amifuse already has improved other projects out there, which I think personally is super cool. And then of course there's like a lot of people now also coming from the open source community jumping in and helping. I want to point out there's Thomas Dye, who's contributed a lot of the Windows port and made it really better. And he's at the moment he's working on having a Windows installer that makes it really seamless, a seamless integration into Windows. Bernie Innocenti has done a lot of testing on a lot of odd images, and also sent patches around. And then Stefan Haubenthal, Pollux, and David Dunkley, of course, also have contributed to the project. At this point, I am very sorry. I wanted to give a demo. I did reinstall my Mac, and I need to reinstall amifuse, and I need to reinstall Fuse itself, which requires a reboot. I did not get to do this right before the call today. I can talk a little bit about how to call amifuse, right? Like there's really a couple of important commands that you need to know. You can install it just on the command line by running pip3 install amifuse, and it will download the latest version and install it in your system. And then you can inspect the partition table using amifuse inspect. If you want to mount it, you can mount it using amifuse mount and then the name of the hard disk image. If you want to see icons, you say dash dash icons. If you want to have read-write support, you say dash dash write. And then you can just like open your volume and do things with it. And then when you're done, you can say amifuse unmount, or you just on the Mac you drag like the volume icon onto your trash can, and it will also unmount. Yep. And that's it. So it turns out sometimes running the original file system is the best way to actually get back to your old files. Yeah. And if you want to look at amifuse, down here you find the GitHub. On my GitHub, there's the repository. Thank you very much. And if you have questions, please ask.
Well, many thanks to you, Stefan. Maybe I have a question. It was not very clear to me. If you just mounting something now, will it detect automatically what kind of disk image it is, or do you need to specify?
It will definitely try to automatically detect what the image is. Yes, and in case of a hard disk image, normally on the Amiga, the file system drivers are stored directly in the partition table. So it will also automatically load the file system from the partition table if it is there. If it's not there, you will have to say dash dash driver and then specify the name of the file system driver, which is on your local hard drive. And
okay,
then you
can force it somehow if you
force it to load another partition, another file system driver, correct? Yeah.
Yeah, super nice. Let me see. I see something in the chat. Is that a question? No, it's a comment. By the way, host environment is now also implemented. I guess that's in the studio. Okay. I don't know if there are any other questions. I would ask people to unmute and ask a question. Otherwise, you can just post it in the chat. I guess Stefan can get back to it and later on.
Good question, if I may.
Sure.
Can we trust it now with our data?
I am definitely running on every check-in. I am running extensive read-write testing. Yes, so to make sure that we are not accidentally overriding anything. So I think it is fairly trustworthy. Now, if you write to it, maybe still keep a backup of your original disk. Just as a safety measure. I do that just because even if it's not amifuse corrupting the file system, sometimes I do something stupid and then I accidentally delete some files I didn't want to delete, right? So it's doing backups obviously is always good, but it's been very stable for the last few releases now. Yes.
You have the little physical click you can put on the disk.
Yeah. And the other thing is, I think if you want to use it with a file system that's not on I have a list of file systems that I am testing. If you find a file system that is not on that list, feel free to try it in read-only mode first, and let me know about it, right? And so I can make sure that I integrate it into the test suite and make sure that that file system is also supported properly. Because some of the file systems, every new file system I try basically brings out like some aspect of Amiga OS that is not fully emulated in VAMOS. And so there, of course, you might run into crashes. Typically, these crashes, even in read-write mode, would not destroy any files on your file system, but it's better to be careful there, right? And so let me know so I can add it and improve it. Yeah.
Great. Many thanks, Stefan. Any last question? Otherwise, you put it in the text, in the chat. Many thanks again, Stefan. I will stop the recording now.